Hey guys, we're gonna go over this curve sketching. We've already gone over this before, so if you guys just want to kind of look over the notes, I'm gonna go over just a little bit differently. But here are some recommendations that you guys consider when you're sketching a curve, okay? So we have to find the domain and range, determine the x and y intercepts and vertical or horizontal asymptotes if it has any. Find the critical points, intervals where it's increasing, decreasing. Locate the max and mins, the local max and min points. The concavity and the points of inflection, then you can sketch the curve, okay? So the first portion, it's talking about how you can start finding the intervals where it's increasing, okay? So we have the function f of x is equal to x squared minus 1 cubed, and we're going to go ahead and find the intervals when it's increasing. Okay, so in order for us to do that, we need to take the derivative, which in this case is going to be the chain rule. So we're going to bring the 3 to the front, rewrite the inside, take away 1 from the top, and then multiply by the derivative of the inside. And if we rearrange this, we have 6x times x squared minus 1 squared. And then we're going to go ahead and set this equal to 0 and figure out when it's d and e. Okay. Alright, the next portion is for us to actually figure out when it's 0. So it's 0 whenever, since we have two things being multiplied each other, we can set them individually equal to 0. So we're going to go ahead and divide by 6 and get x is equal to 0. Okay. And then here we're going to go ahead and set the other portion equal to 0. So x squared minus 1 squared equal to 0. The square doesn't have an effect on it being equal to 0, so I'm just gonna set x squared minus 1 equal to 0. We get x squared equals to 1. Alright, so we have the points in which this is equal to 0, okay? So we just set them individually equal to 0. And we also have to figure out when it's d and e, because there's a possibility when we're trying to figure out the max and mins that you can have a max or a min at when it's undefined. But since this is a polynomial, it's never undefined, okay? So here what we're going to do is we're going to create a number line, and this number line is going to help us determine where the max and mins are, okay? You know what, actually I forgot to solve for this completely. When you take the square root of this side, you have to put plus or minus, and you get x is equal to plus or minus 1, okay? So we have our 3 critical values. So we have -1, 0, and 1, okay? So here the top portion is going to denote the derivative, and the bottom is going to be the original function. So here we're going to go ahead and plug in -2. Okay, so here when we plug in -2, just picture this. I'm going to plug it into this one. This second portion is always going to produce positive numbers because it's squared. Anything squared is positive. Whereas this one, it's pretty much going to determine whether it's positive or negative. So for example, if I plug in a number that's in this region into my derivative, this is going to determine, so since I'm plugging a negative in there, it's all going to be less than 0, so this is negative, and that means your function is decreasing, okay? I'm also going to plug in another value between here and here, so since I'm going to plug in a negative answer, let's say -1/2, it's also going to be less than 0 because this determines whether if it's going to be negative or positive, so it's less than 0 and it's decreasing, okay? Alright, f prime of 1/2. Okay, so once again, since it's positive, it's going to be greater than 0. So this is plus and it's increasing. And f prime of 2, which is greater than 0, which is positive and it's increasing. Okay, alright, so that's pretty much going to be a tool for you to figure out when it's increasing and decreasing. So what we can do now, just remember that the AP exam is not going to analyze this. This is just for you to organize your own material, okay? So we're going to say, while it doesn't ask us to justify, we can say f is increasing on the interval x 0 to 1 and x is greater than 1, and the reason being is because f prime of x is greater than 0 there, okay? Alright, the next portion here, going back to this paper, it's asking us find the x and y coordinates of the relative max and relative min, justify. So if we take a look back at our number line, if you notice here, we don't have any maxes because it's all going down to down, then to up, and then to up. So there's no point in which it goes up to down. The only thing that we do have is a relative min, and it's located at x equals 0. So what I'm going to do is I'm going to go ahead and figure out what the y value of that is by plugging into the original. So here I'm going to say 0 squared minus 1 cubed, which ends up being negative 1 cubed, which is a negative 1, right? So now I can say f has a relative minimum of negative 1 at x equals 0 because f prime of x changes sign from negative to positive. So the reason I asked you guys to do this right here is because you're basically going to be asked to describe what's going on here. So here we did. So we figured out that this is the minimum, and the reason being is because in this interval we know it's changing, the derivative is changing from negative to positive at this point. Okay, so that takes care of that. The next portion, it's asking for what values of x is the graph of f concave up. Okay, so now in order for us to answer that question, we need to figure out what the second derivative is. Okay, so we know what the first derivative is. It's 6x times x squared minus 1 squared. Okay, so we're going to go ahead and do the product rule. So the derivative of the first 6x is 6 times the second x squared minus 1 squared plus the first, so just 6x, and then the derivative of the second, which is the chain rule. So move the power 2 to the front, so it's 2 times the inside, leaving the inside alone, and then take away 1 from the power is just 1, times the derivative of the inside, which is 2x. Okay, I'm going to go ahead and simplify this a little bit further so that we can go ahead and solve for x. Okay, so it's going to be 6 times x squared minus 1 squared, and then 2 times 6 is 24. X times x is x squared, and then we have x squared minus 1. Okay, and we're going to end up setting this equal to 0 and figuring out when it's undefined as well. Okay, so since this is a polynomial, we can rule out the d and e, and so we're going to figure out when it's equal to 0. Your best bet is to factor. It's very, very difficult to isolate. So we're going to factor out so this term and this term, what they share in common is a 6. So I'm going to take it as 6. And we're also going to factor out an x squared minus 1 from both of them. Okay? So here, we're going to take out 1, so it's going to be x squared minus 1. Plus, if I factor out this entire thing, it's going to be 24x squared. Okay? Equals to 0. So just simplify it a little bit further. You know what? I'm sorry. This is not a 24x squared. We're factoring out a 6, so it's going to be a 4x squared. Okay, so now we're going to have 6 times x squared minus 1. Combine the 4x squared and the x squared, it becomes a 5x squared minus 1 equals to 0. So now that we have two polynomials being multiplied to each other, we can go ahead and set them individually equal to 0. And we also have 5x squared minus 1 equals to 0. Now if you write the 6 here, the 6 has no, it doesn't change whether this is going to be equal to 0 or not. Whether it's there or not, the value of x that you plug in here is going to be, make the entire thing equal to 0 whether that 6 is there. So I'm going to go ahead and set just this equal to 0. And if you do some algebra, we get that the answer is going to be plus or minus 1. Okay, here we get 5x squared is equal to 1. Divide by 5 on both sides, we get 1/5. And when we take the square root, we get plus or minus, the square root of 1 is 1. And the square root of 5, well, I'm just going to leave it like that. Okay? Alright, so we're going to determine the point in which it's concave up. So I'm going to go ahead and do our number line. We're going to get -1, -1 over the square root of 5, 1 over the square root of 5, and 1. Okay? And I know that this is less than, is going to be actually greater than -1, and this 1 over the square root of 5 is less than 1, so that's why it's in that order. Here I'm going to write f double prime and f, and I'm going to start plugging in some numbers. Okay, so let's go ahead and start off with f double prime of -2. Okay, so I'm going to plug this into this portion here because it seems a lot easier since I have two things being multiplied to each other. So I'm going to determine what this is. So I'm going to plug in -2 in here. So -2 squared is 4. 4 minus 1 is a positive number. Okay, and here I plug in -2. -2 is 4. -2 squared is 4. 4 times 5 is 20. Minus 1 is 19. So that's also a positive number, which is greater than 0. Okay, and here it's going to be positive, so that means it's concave up. Okay, all right. The second derivative is going to be I have to figure out a number that falls between here and here. Okay, so I know that 1 over the square root of 9 and 1 over the square root of 4. 1 over the square root of 4 is 1/2. Okay, so I know that this is less than, if I put a negative here, I know that this is less than this one, so it's going to fall in this region. And I know this portion is going to be 1/3, but since we're taking the square root of 9, that's meaning it's going to be falling to the left of this region. Okay, so I'm going to plug in 1/3. Okay, so 1/3, -1/3. These are negative. And I'm going to go ahead and plug it into this function here. Okay, so it's going to be 1/3 cubed, squared is 1/9 minus 1. Okay, and then here I'm going to have -1/3 squared is 1/9 times 5 is 5/9 minus 1. Okay, so here this produces a negative, this produces a positive, which makes it less than 0. So it's going to be negative, so that means it's concave down here. Okay, the other portion here we have the second derivative of, we can plug in 0. That one's not too bad. Okay, we're going to plug in 0, and it turns out that when we plug in 0, we get a negative answer times another negative answer, which makes it positive. So it's going to be greater than 0. So here it's plus, and it's concave up. Okay, here's another portion, the second derivative. I'm going to go ahead and plug in 1/2, but if you notice here, this is being squared, this is being squared, so it's going to produce the same answer. Actually, I'm sorry, not 1/2, 1/3. It's going to produce the same answer as this one. Okay, so I know that it's going to be less than 0. Okay, because anything squared is always going to be positive, so it's going to produce that 1/9 again. Okay, so it's going to be less than 0, so that means it's concave down. And then I can plug in the same answer over here, f double prime of +2, just like I did here. And just the case like this one, it's going to be the same value. It's going to be greater than 0, and that's going to be positive, so it's going to be concave up. Okay, all right, so now we know that it's concave up in this region, and this region. All right, so now it's asking us what to do next. It's asking us to sketch the graph of f now, given all the information that we have. Okay, so we have this domain and range that we haven't figured out yet, but if you notice here, the domain is going to be all real numbers, and then the range is also going to be all real numbers because it's cubed. So I can plug any number in and I'll get a number back. Okay. The next one's asking for the x and y intercepts and vertical asymptotes. I can exclude the vertical and horizontal asymptotes because this is never undefined, nor does it have any horizontal asymptotes. And then the x and y intercepts, I'll take care of it in a minute. So what I'm going to do here is I'm going to start graphing. I'm going to create my number line, my coordinate plane, and I'm going to go ahead and start putting some key points in. Okay, and my key points come from this number line that I created. So I'm going to put a -1 here and a +1 here, because I know that's where I'm going to have a horizontal tangent, and I also know I have a min here. Okay, so what I'm going to do as a side note is I'm going to plug in 0 into my function. So I'm going to get -1 cubed, which is -1. So here I'm going to have a minimum there. Okay, all right. And the other portion is I'm going to plug in -1 just to see where my horizontal tangents are. So I will plug in -1 into my function here. I'm going to get -1 squared is 1 minus 1 cubed is 0. So here I'm going to get a 0. And if I plug in 1, I'm going to get the same answer, and it's going to be 0. Okay. All right, so those are my key points as far as this one. Now I'm going to go ahead and plug in the key points for these years. So -1, 1, -1 over the square root of 5, and 1 over the square root of 5. So I already plug in -1 and 1, so I'm going to plug in 1 over the square root of 5 into my function. And let me just go ahead and write the function in here. It's f of x is equal to x squared minus 1 cubed. So I'm going to plug this into here. So this squared is 1 over 5 minus 1 cubed. And this ends up being 4/5 cubed. And 4 cubed is 64, and this is 125. So I'm going to have to estimate this. And then it's going to be, this is actually a negative, so it makes this negative. So here I'm going to go ahead and plug in at this point. This is negative 1 over the square root of 5. I'm going to estimate this. This is about a little less than half, so I'm going to put a dot here. Okay, and then it turns out these are symmetrical, so I'm going to put a dot here where it's 1 over the square root of 5. I'm going to put the same level. Okay, and it turns out that these are the x-intercepts of this portion as well. So when I go back to this one, and it's asking for the x and y-intercepts, it turns out that the minimum is the y-intercept, and the x-intercepts are your two points in which there's a horizontal tangent. Okay, all right. So now this is what I'm going to do. I'm going to go ahead and start from left to right. So I know that I'm decreasing before -1, and I'm also concave down. So starting from over here, I'm going to decrease and be concave down at this point. So I'm decreasing concave down. And I also know that at exactly -1, I have a horizontal tangent. So I have to make sure it's a horizontal tangent there, and that it's changing concavity from here to here. So it's a sketch, all right? So here's concave down, it's still decreasing. And then after that, it's still decreasing all the way up to 0, but it's concave up after the -1 over the square root of 5. So I'm going to come here. Okay. Now if you remember also, it's also after this point, if you look at your number line, it's increasing and it's concave up, and then it's increasing still, but it's concave down, and then after that it's increasing and there's a horizontal tangent here. So this should be more or less, well, this should be symmetrical. Okay, my sketch is a little off. Okay, and this is your graph.